I'll tell a little bit about myself, my background, my technical background. I was born in New Delhi in India. From a young age I was very interested in science. Science, I felt, had the power of explaining things that looked very, very complicated and unbelievable. And through science you could understand why the sky is blue and simple things like that, but even more complicated things. So I was always interested in science from a young age. I went to University of Delhi to study physics, and I got my bachelor's and master's degree in physics. Then I applied to universities in USA, and I was very fortunate to be admitted to University of Chicago, which is an outstanding university for many fields and especially in physics. And when I got to University of Chicago, my main interest was high energy physics, and I wanted to study high energy physics because I felt that explained the origins of everything, of the universe. And I had read a lot of books from and about Feynman, Gell-Mann, and many of these outstanding scientists, and I wanted to be like them. I was assigned an academic advisor, Professor Ome, who was in particle physics, high energy physics, and he advised me very strongly that the opportunities in high energy physics were dwindling, they were very small, and he advised me and encouraged me to look at some other aspects of physics. So I switched and I started looking at solid state physics, and it was a very fortunate and very beneficial advice from Professor Ome. I joined Professor Morel Cohen and I studied solid state physics. Chicago is known for pure physics. It has no engineering department, but I was fortunate to work in an area which was more applied because that's where my mind is more interested in. And I worked at that time in solar cells, amorphous silicon solar cells, and this was a period of oil shock, so there was a lot of interest in renewable energy, and I got a fellowship from General Electric to study solar cells. So I worked in amorphous silicon, both in structural properties of amorphous silicon and especially in electronic properties, in localized states, band tail states, mobility edge, and those kind of things. And I got my PhD in amorphous silicon electronic properties in 1980, and then I went to University of Southern California to do postdoctoral work, and I continued working in semiconductors, but I started moving more and more towards heterostructures. And at that time there was a lot of interest in, because heterostructures were new and people were able to grow quantum wells and low dimensional systems in semiconductors. So I was very interested in gallium arsenide, aluminum gallium arsenide heterostructures, interfaces. So I worked at interfaces, electronic properties, optoelectronic properties. And I was at USC from 80 to 83, and then I went to Wright-Patterson Air Force Labs, where there was a large group, and they were all mostly experimentalists working in understanding excitonic effects in quantum wells, mobility in heterostructures. So I had a lot of interesting data from all over the world that I could look at, and that was like a gold mine for theorists. In 1985 I was fortunate to be hired at University of Michigan in Ann Arbor, and I've been there since. I've taken a couple of sabbaticals. I've gone to University of Tokyo and UC Santa Barbara. My area of research remains semiconductors, and since I started in 75 to now, close to 38 years, semiconductors have transformed human experience, and they've transformed societies, how we play, how we entertain, how we interact with each other, devices all the way from computers to laptops, tablets, cell phones, video cameras. All of those are driven by the intelligence from semiconductors. So I work in all kinds of semiconductors, from silicon to gallium arsenide, germanium, all the way to nitrides. I look at heterostructures and the physics of low dimensional systems, and how this physics, especially particularly how the physics can be used to design new kind of electronic devices, new kind of light emitters, and new kind of sensors in general. I also have a lot of interest in education. So I published 10 books, which are textbooks. They range from physics of heterostructures, quantum mechanics, transistors, light emitters, and so on. I also have published some books in cultural issues relating to good life, and what good life means. They are more cultural books related to the country I was born in, India. I have had the opportunity to work with many outstanding students, and I'm very proud of my students and what they've been doing since they graduated. So that gives a synopsis of what my interests are. Thank you.